Welcome back, everybody. So here's the warm-up again. It would be a good idea if you did the warm-up, wrote down your answers, checked your answers, and then, so pause it and then play whenever you're ready. We're going to go over it right now. All right, so what do I do to find prime factorization? What's that thing that I draw? Factor tree, the good old factor tree. So let me ask you this, Mackenzie. What is the prime factorization of 38?
2 times 19.
Yeah, that's a quick one, right? 2 times 19. All right, that's it. 2 times 19. Nevaeh, what's the prime factorization for 68?
2 times 2 times 17.
2 times 2 times 17. Now, remember, how do you check this? Well, you could always go back in and say, okay, 2 times 2 times 17. Did that give me 68 back out again? Yeah, then I know I got it right. As long as all the numbers that I had written are prime numbers, like 17 is a prime, 2 and 2 are prime. Travis, what did you get for 24? 2 times 2 times 2 times 3. Good. Very good. I could have also written that 2 to the third times 3. All right, now, identifying the GCF. Not necessarily doing anything with it, but just identifying what the GCF is. Carson, what is the GCF between 36 and 24? 12. Good. 12 is my GCF. Be honest, did you say 6? Because that's a very common response to try to just say 6. 12 is the GCF. Again, I always think about it like this. What's the biggest number that divides 24? Well, 24 itself, because 36 divided by 24. No. So what's the next biggest number that divides 24? We'll cut it in half. 12. That's the next biggest number that divides 24. And then you go back and you say, okay, 36. Divide by 12? Yeah, that works. Okay. Number 5, Baker. What's the GCF between 6x to the third and 2x to the fifth? 2x to the third. Good. You take the GCF of the two numbers, 6 and 2, they're both divisible by 2. And then you take the smaller of the two variables, so the smaller of the two powers. So 2x to the third. Alex, what's the GCF of 6?
2x to the second and 1.
X to the second and then y. I like the x to the second and y, but I think there's something.
I said 2 and then x to the second y.
I know. I think there's something bigger than 2.
4.
Bigger. 6. 6. Yeah. Think about it. Go with 18. Smaller number, 18. Can I take 24 divided by 18? No. So drop 18 in half, 9. Can I take 24 divided by 9? No. So keep going. What's the next biggest factor of 18 below 9? 6. Yeah, 24 divided by 6. And there, you see the smaller power on x is squared. The smaller power on y is just y to the first. Always go with the smaller power. All right. Number 7, factor by GCF. Now again, 7 and 8, this is where the new stuff comes in. Not just identifying what the GCF is, but also doing something with that GCF. So let me ask you this, Elena, what is the GCF of these two terms? 2x, good. So remember, we write the GCF, we start our parenthesis, and then we divide it out of each term. What's left over after I remove the 2x from the first term? Just an x, good. And what about if I remove it from the second term? Socks?
Man, that's embarrassing.
I'm sorry, Elena. I got distracted by socks. What's left over after I divide out 2x from 8x? Just 4. I got to be honest. That's the first time anybody has delivered socks.
Yeah, I was gonna say, who's like?
That's not that is a first. 11th year of teaching. First time socks have been delivered to them. Questions about that? Okay, let's take a look at the next one then. Rosalie, what's my GCF of those 3 terms? Good, 4. I'm glad we didn't say 2. A lot of people might try to say 2, but it's the full 4. And then you said x to the what? Watch out, smallest power. Second. So you pull it out and you put it in front of the parenthesis, and then you divide it out of each part. 4x squared comes out of each piece here.
Keep forgetting this that extra stuff.
Of dividing it out.
Yeah, and then just keep 4.
What's left over in the first one? Okay, do it with me here. What's 16 divided by 4? 4. I've got x to the 5th over x squared. What's left over? X to the 3rd. Good. 4 divided by 4, that's a 1, right? So let's just write x to the what? First. 3 minus 1. I don't even need that first power, do I? Then 8 divided by 4 is what? 2. There's no more x's left over. Does that make sense? Okay. All right, how do we do on the warm-up? Do we do okay? Everything but the last two?
Yeah.
All right, let's go over the homework. Now, I actually have, these are all the answers, right? Yeah, I actually have all of the answers here for you. So if you wanted to, you can check your answers for all of these, 2 through 10, or 1 through 10, excuse me. Did everybody get my remind? The Canvas assignment was wrong up until about 4th period. And then or 5th period maybe, and then I got corrected.
Yeah, I think it was I don't know if it was Monday night or Tuesday night, but you were up at 11 changing the due dates on everything.
Yeah.
Yeah.
That's when I get my work done.
Yeah. I woke up and had 17 notifications.
I know. Well, it's so stupid because when I publish a module,
Yeah.
because everything's in there from last year, all of the assignments are already created. So when I publish a module, it's so stupid. It publishes everything in that module. So we started chapter 8. So I had to publish chapter 8, and it published everything in that module.
I'm sitting there
I know.
it's up late.
And then all of those assignments are coming through notifications. Can we stop that? I want to turn that off, but I can't. Anyway. But yeah, that's when I do my work. Kids go to bed 8, make lunches for the next day, 8:30, 9 to 11, that's my prime working time.
Yeah.
Yeah. So I get my work done. Baker.
Can we go over some of the questions that have a negative in front of them?
Sure, pick one. 3, 4?
Yeah, we'll go through.
3. Okay, let's take a look at 3. Now, how do I know that I'll have to remove the negative? Because it leads with a negative when it's in standard form. You see that? So I know I've got to do something with it, right? So negative 35x plus 42. It leads with a negative, so therefore I have to remove the negative as a GCF. I then take a look at just the numbers, 35 and 42. Well, they're both divisible by 7, right? So I remove negative 7 as a GCF. Then I divide each piece by negative 7. And that's a key part to this. You have to divide by the negative because it will flip the sign. I divide by negative 7 and I divide by negative 7. So negative divided by negative turns into a positive 5x. Right. Correct. And then 42 divided by negative 7 is a negative 6. You keep the negative on the outside, Nate. Is that what you were asking? Yeah, you keep it on the outside. It gets removed just like the GCF gets removed. It gets removed, but it stays on the outside. Okay. Let me scroll back down to the answers. Let's do 1 or 2 more of these. Elena, pick another one to do. You can pick any one you want, 1 to 10. 8. Let's take a look at 8 real quick. Now, first thing that I would say with this one is that it's not in standard form. I would like to say, I don't know, did I do that in 8? Yeah, I did put it into standard form, good. For number 8, I'd say 14n to the 3rd plus 7n squared plus 7n. Remember, standard form goes from biggest to smallest in terms of the degree. And now I'd say, okay, what's my GCF? Well, I see 14, 7, and 7. Those are pretty easy numbers. 7 is my GCF. 7. Is it just 7, though? What's my full GCF? Travis? 7n. 7n is my GCF. So that's what gets removed out of everything. All right. So 14 divided by 7 is 2. N to the third divided by n to the first is an n to the second. 7 divided by 7 is 1. N to the second divided by n to the first is just n to the first, or just n. 7n divided by 7n is 1. Watch out for that one. That's a key piece there that a lot of people mess up. If you remove all parts to a term, it turns into a 1. It doesn't just go away. It's not a 0. It turns into a 1. Okay. Let's go flip over to the next page here. There's 12, 13, and 14. These problems right here are going to set us up to do what we need to do today. What do you notice about 12 and 13? What is in the parentheses?
Negative.
Not necessarily.
M.
I'm talking about 12 and 13. What do you notice?
They're both the same.
They're the same. That's what I want you to get out of that. They're the same. The parentheses are always the same. If the parentheses are the same, that is my GCF. That's what I can remove. I can remove the m minus 2. It comes out, start my parenthesis, what's left over, 5 minus m. The b plus 3. Comes out, what's left over, 2b plus 5. Can I do that with 14? No. Why not? Because the parentheses are not the same. I've got an x minus 3 and a y plus 2. I cannot do that two parentheses. Okay. All right, questions about those three? No? Okay. Let's do our notes for today. Now, what we're going to do today, look, only one side to our guided notes today. Let's go. Get some work on our homework done today. What we're going to do today is kind of putting a little bit in front of those last couple problems. Okay? Those ones where we had the common pieces being that whole binomial, that whole thing inside the parentheses. You're welcome. All right. Now, you may be able to factor a polynomial by what's called grouping. Factoring by grouping. Oh, you know what? Here it is. All right. We may be able to factor by what's called grouping, okay? When a polynomial has 4 terms, okay, I want everybody to underline grouping, and then I want everybody to put a squiggle underneath 4 terms. Whenever you have 4 terms, you can do this thing called factoring by grouping. Factoring by grouping. It's, in fact, the only way you know how to factor something by 4 terms. All the way through Algebra 2. There's no other way to factor something that has 4 terms. You have to do something that's called grouping. And if it doesn't factor by grouping, then it's what's called prime or not factorable. Okay? So, take a look at this first example. Factor by grouping. Factor by grouping. Now, obviously the name says grouping. I've got to group some sets of these terms. Everybody underline the first 2 terms and underline the last 2 terms. Underline the first 2 terms, underline the last 2 terms. Let me ask you this. What's my GCF of my first 2 terms? Just the first 2 terms. 2h to the third. 2h to the third. 2h to the third. So let's factor out that GCF of just my first 2 terms. 2h to the third. That means that divides out 2h to the third, 2h to the third. So I get, well, what's left over on the inside? A 3h minus what? Just a 2. Because I pulled out the full h to the third, so that goes away. All right, what's my GCF between my second two terms? 5. So let's remove that GCF. And it's a positive 5, right? I'm not pulling out a negative 5. The only way you would pull out a negative is if this was a negative. So let's pull out a positive 5. So that gets me a 3h minus 2. Holy chicken nuggets. What happened? That's not my answer.
Oh, they turned out.
Oh, they turned out to be the same things as what we had on our homework. Look at the parentheses. They're the same. They're the same. So what can we do now? Yeah, we can say, okay, that must mean 3h minus 2, right? See the common piece there? 3h minus 2 comes out. What's left over? 2h to the third plus 5. And that's my final answer. See, those problems that we did yesterday and the ones at the end of our homework, we're kind of getting you ready to do this. Forcing you to recognize when we have those two sets of parentheses that are exactly the same. Because if you can see that, then it does factor by grouping. Now, what happens if you group and you remove a GCF and I don't have common pieces inside my parentheses? It's prime or not factorable. So you've done a little work, but unfortunately you have to go back and say, oops, not factorable. All right, let's take a look at our next one here. This is your next one, right? 6b to the, yeah. So again, we underline our first two terms. We underline our last two terms. You always separate it with 2 terms and 2 terms. Because it's 4 terms. This only works with 4 terms. So you're going to separate it 2 and 2. All right, what's my GCF of my first 2 terms? 2b to the second. So let's divide it out. 2b to the second, 2b to the second. All right. 3b is my first term. Plus what? Just 4. What's my GCF of my second 2 terms? Just a 3. Not even a b. But it's positive, right? Positive 3. So we divide that out. Oh my goodness. Oops, I forgot to write my 3. 3b plus 4. Magic. So look, inside the parentheses, exactly the same. There's my common piece. Remove the common piece. 3b plus 4. Start my parenthesis. Write what's left over. 2b squared plus 3. Good. Again, this is called factoring by grouping. This is the only way you could do something with a 4-term polynomial. Yes?
They're always going to be the ones right next to each other that are going to be the ones, or can you mismatch?
Good question. You can possibly mismatch them, but here's what I would say. Try to keep it in standard form. Keep it in standard form. The ones where you have to mismatch are very tricky. Like this one. Let me just think about something here. I removed that before. Yeah, is this in standard form? No. Let's put it into standard form and see what happens. 4r to the third plus r squared plus 24r plus 6. Should. Yep. This one will actually work if you don't put it into standard form, but that's not always the case. All right, we group first 2, last 2. What's my GCF of the first 2? Just r squared, right? Not even any numbers, just r squared. So that means we get a 4r plus what? Plus 0? plus 1. What's my GCF of my second two terms? 6. A positive 6. What's left over? 4r plus 1. And look at that. 4r plus 1 with an r squared plus 6 left over. Now, it may look like, because we've done 3 that work, it may look like this always works. Does this always work? No, this does not always work. If it doesn't work, then it's prime. It's not factorable. Okay, but let's see. Now, is this in standard form? No, let's put it into standard form. I've got 2x to the third minus 12x squared minus 3x plus 18. This one's going to get a little funky.
Did you do negative 2?
What's that?
Are you going to do negative 2 for the GCF?
Okay, he asked, are we going to do negative 2 for the GCF? For the first one, no. You only do a negative GCF when it leads with a negative. Now, that will come into play on this problem.
So it's going to be 2 then?
2 what?
2x to the second.
2x to the second. That's my GCF. So now, what's left over? X minus 6, right? You follow me there? Okay, what's my GCF? What am I going to pull out of my second two terms?
3.
A negative 3. Do you see how it leads with a negative? Negative 3x plus 18. When it leads with a negative, your GCF must include a negative. So it's a negative 3, which is just kind of like a minus 3 in our case here. All right, now be careful. I've got to divide out a negative 3. So that's going to leave me with a positive x on the inside and a negative 6 on the inside. And look at that. It's one of those ones that didn't look like it was going to happen, but it did. X minus 6 is the common piece. And what's left over? 2x squared minus 3. So the trickiest it can get is when you have to remove a negative. When you have to factor out a negative, when there's a minus sign sitting in the middle of these 4 terms. That's about as tricky as it can get for what we're doing. Take a look here. I've got 15x squared minus 10x to the third plus 8x minus 12. Is that in standard form?
No.
It's not. Negative 10x to the third has to come first. Then the plus 15x squared. Then the plus 8x minus 12. All right, take a look. What's the GCF of my first two terms? 5. X squared, right? 5x. Actually, yeah. Negative 5x squared. Yeah, watch out for that. I led with a negative, didn't I? So I've got to remove it. Negative 5x squared. All right, so here we go. Negative 10 divided by negative 5 is positive 2. And then I have my x. Positive 15 divided by negative 5 is a negative 3. What's my GCF of 8x minus 12? 4. Positive 4, right? Okay, let's see. 8 divided by 4, 2. 12 divided by 4, 3. Sweet, this one was factorable too. So I've got a 2x, 2x minus 3. Start my parenthesis. Leftovers are negative 5x squared plus 4. Does this have this problem on it? Yeah. Okay, good. Last problem here. A rocket is fired vertically into the air, 40 meters per second. the expression -5 t squared plus 40t plus 20 gives a rocket height after t seconds. Factor that expression. You actually learned a lot in Algebra 2 about what's called projectile motion, which helps you get ready for physics. But what you are looking at here is that an equation that models the path of a rocket. Any rocket is what's called parabolic. It's in that U shape, just upside down. Anything thrown, anything projectile. -5t squared plus 40t plus 20. It just says factor that expression. Now, let me ask you this. How many terms do you see?
30.
Can I do factoring by grouping?
No.
No, I cannot do factoring by grouping. So what do we have to do here? Well, what's the only thing I could possibly do? Not factor, just factor by GCF. What's the GCF to this? -5. -5. Don't just say 5, it's -5. So let's remove it, -5. All right, what's left over? That means we got a t squared minus 8t minus 20 divided by 5, 4. And that's all we can do right now, because that's all it asks us to do. It just said factor this expression. So that's all we needed to do. Not too bad, right? Okay. I'm giving you a little bit of time, so go ahead. I'll bring up the book pages real quick. So nice that it's right up here. Just bring it up real quick. Page 535, chapter 8. Page 535. 28 to 42 even. So this bottom part evens, and then 43 to 51. Okay, go ahead and do some of this. You can at least get a good chunk of it done. You shouldn't take you that long. Oh, hold on.